Hello everyone, welcome from Finland. I'm Cagatay. I'm a software developer at Wolt. I was actually hired as an Android developer, but luckily nowadays I'm only doing Flutter development. So today my topic is from motion specs to Flutter code. We will start with rendering pipeline and then understand how the framework works. Then we will talk about the motion specs, which sits between the design and implementation. So before starting, I also would like to thank to the organizers and thank you for bringing the community together. So let's start. Although now I am the only one who is presenting today, this is actually the result of a teamwork. Scott and Maria, they are the ones behind the design. Scott did the UI design, and Maria provided these motion specs to me. And then I implemented the Flutter code. Today, you can access the demo application that I will show soon in my GitHub repository. This is actually a big concept called multi-page scrollable bottom sheet, and I would like to mention 4 steps when presenting this. So as a first step, with designers, we had this talk at Flutter Global Summit, Flutter Global Summit Volume 2. And there, Scott and Masha talked about the design specs and motion specs, UI design and motion specs, and the reasonings behind those. So how the bottom sheet is used, why is it important? And Masha talked about the decisions behind these behaviors of the UI components in the bottom sheet. And I had only 17 minutes to explain the Flutter code implementation. As you can imagine, it was really challenging. So as a second step, I decided to have a talk in a longer time just to explain this Flutter deep dive, which is necessary to understand this multi-page scrollable bottom sheet implementation. And today, now we are in the third step. I have again 30 minutes to explain how to implement the motion specs that are provided by our motion designer and implement the Flutter code accordingly. And finally, after all this, I will publish all my learnings in my Medium series of articles. And before going to the next slide, I would like to briefly mention that we are hiring at Wolt, and if you would like to join our Flutter team, let's be in touch. Okay, let's start. Flutter is fast. Depending on the device capability, Flutter can deliver 60 or 120 frames per second performance. Why is it fast? Because it's simple, and simple is fast. I took this phrase from Adam Bart's YouTube talk, Flutter's rendering pipeline. So it is, I think, a bit more than 1 hour, but it talks about the topic extensively, which is, I still think that it is still not enough to understand everything. But anyway, so Flutter is performant and fast by design thanks to Skia, its own rendering library, and a simple rendering pipeline, which we will talk about today. So what is the first method that we call when starting a Flutter app? It is run app method, right? Inside this method, framework does 2 things. One, root widget is attached to the widget tree. Widget tree is created actually, and then element tree and render object tree created from top to bottom. And then the second thing is that framework initializes the widgets Flutter binding class. It is really important class. It's a glue between the engine layer and the framework layer. This class contains 2 important classes for rendering pipeline. One is the build owner. The other is pipeline owner. Here, you see them. These are the manager classes. So how does the framework produce a frame? This is about rendering pipeline, producing a frame. When it is time to produce a frame, the engine calls draw frame method on widgets binding, which starts the rendering pipeline with the build phase. The build owner class is the manager of the build phase, where all the dirty elements in the widget tree are rebuilt. And after the build phase, we have the pipeline owner class, which manages the laying out, painting, compositing, and generating the drawing instructions. The output of the paint phase is the layer tree, which is consumed for rasterizing and compositing. And the final output is translated to GPU render instructions. to draw pixels on screen. So in the end of the rendering pipeline, we see the pixels in the screen. So what is our role as developers in the rendering pipeline? Simple, two things. One is provide a widget tree to the framework so that the build phase starts with that. And then we mark the widgets in the widget tree as dirty. For example, when we press a button, we call set state in a stateful widget, and this widget becomes dirty, and in the next frame, it will be revealed. Okay, let's now cover how Flutter optimizes the amount of work by reusing the element and render objects as much as possible. The phases in the rendering pipeline has one direction, from top to down. And in the build phase, elements are examined by parents from top to down. So according to this examination, framework decides whether a child element can be reused, a new child element should be created, or the existing child element should be removed from the element tree. And this examination is done in the update child method, which is, according to Flutter documentation, it is the core of the widget system. Let's now see the possible scenarios with update child. So in the first scenario, we have the existing child element, but in this build phase, there is no corresponding widget for this child element. So element is not needed. And elements marked as deactivated, inactive. And then at the end of the rendering pipeline, at the end of the build phase, the element is still, if it is not reused in anywhere of the tree, it will be demounted, its resources will be cleared. In the second case, we have this element, but now we have the new widget. So in this case, the last widget in that child element is compared with the new widget for that child element. If they have the same reference, then we reuse the element as it is. We don't update element, we don't update the child render object. This is really actually where we want to be from performance point, because this is preventing extra builds. And this is also why we use const widgets. And in this third case, we have element, we have new widget, but this time the references are different. So in this case, there is this can update method. We will check with this method if we can still reuse this element. If the runtime type of the widget, old widget, is same as the runtime time of the current widget, and if the keys are the same, then widget can be reused, element is updated, render object of that widget is updated. In the fourth case, can update returns false, so we don't have any option than creating a new element and removing the existing element. But this is also expensive in terms of performance, because we are creating element, we are creating a new render object. And in the last case, we don't have an element, but we have a new widget to be inflated. So in this case, of course, a new element will be created. So this was how the update chart works. Now we are going to see this rendering pipeline in the big picture. We have this widget tree, and then there is this stateful widget. And in the state object of this widget, there is this widget subtree. And when we press the L, widget L, the on pressed button, let's say it's a button and we press on pressed. So then we press it, the button actually, yes. And then what happens there? We set the state. We call the set state method, which marks the element C as dirty. And in the next, build owner knows that this element is dirty and adds it to the list of dirty elements. When a new frame starts, widget binding first calls draw frame, which build owner starts build scope, which starts the build phase, starting from top. And then all the dirty elements are rebuilt one by one. So update child method is called on E, then it will be called from top to down. But let's see that element E can be updated, and then its render object is updated. If the widget configuration changes so that it has a different width, which requires again performing another layout, then the layout is marked as dirty. For example, if the opacity of the widget configuration, opacity of the widget changes, then it needs a paint. So in the paint phase, it will be painted, and so on. So here, build phase is completed. Now, pipeline owner starts the rest of the stages. First, layout phase, then compositing bits, and then paint phase. After the paint phase, we have a layout tree, and then root render object sends bits to GPU, semantics sent to the OS, operating system, and then build is completed by calling final as tree on build owner. After the just enough technical background, now we can start talking about motion. Masha explained in her talk at Flutter Global Summit Volume 2, she said that motion sits in between design and development. Let's see what motion she's talking about on our demo app. Here, first the scroll motion. We have this bottom sheet page. As we scroll, the top bar gets visible, top bar title gets visible, and then it goes down. Translation Y, transformation. And now we go to another page. We have a hero image this time, and still we have the same. Top bar gets visible as the scroll position changes. And the second one is this pagination. Now I'm showing with, sorry, this was supposed to be the first page. Okay, this is the first page you see. And then let's see. Here the animations are slow to show the transitions clearly. So what I want to show in the end that there is this pagination, the sizes of the pages are different, and now we have this motion, and when we don't have these translations with speed, I can easily show here that this is Apple, you know. That's I don't know why it is not working with this simulator. Yeah, this is the animation that motion animation that I'm talking about. Anyway, let's go back. This is what we are going to achieve today. Okay, scrolling in the page spec. So after the motion designer chooses a suitable approach for the motion, she delivers specs to the developers. The specs is basically the changes in the parameters based on the scroll distance here. These parameters are translation, scale, and alpha. How do we calculate the transform value? Well, here, every component has a height, donated here, so notated here. And then we do the calculation. We calculate the progress, and then we find the actual value within the lower limit and upper limit. Okay, now flow widget. The scrolling motion specification relies on the size of the UI components. And among these components, top bar title, and the hero image has fixed size. But the page title has intrinsic height, and we cannot know its size before laying out. In the rendering pipeline, what we do is providing a widget tree, right? We can actually use size transition, opacity, and slide transition widgets to describe these changes on the properties. But the main challenge is that we need to first lay out the page title to do this logic. We can actually go in the rendering layer and play with the render objects to implement custom layout. But this is risky and too complex because if we do things wrong, we will have performance issues. But widget library provides us this flow widget. It will be very helpful transforming these components with using its delegate. Here, we will have two flow widgets, one for hero image and one for top bar title and top bar. So let's now analyze the delegate of the hero image, which is hero image delegate. Okay, in this delegate, we will paint the children in the paint phase. We will calculate the transformation value based on the scroll position. We have the scroll position provided from the scroll controller. So let me remind again, this hero image is inside this main content, which is a scrollable list. And then it has a scroll position, which is a listenable, which is holding this scroll position in pixels. Okay, having this value, pixel value, current scroll position, we can calculate the transformation value calculate the opacity, calculate the transformation value for scale, and calculate the opacity, and then paint the chart with a transformation matrix, such as matrix diagonal 3 values. Here, we provide the scale factors in X and Y, and then provide the opacity. Then the paint child paints the child, actually, paints the hero image. Now for top bar delegate, it is very similar to the hero image, but here the difference is that we are actually using page title height in these calculations. How do we get the page title height in this top bar? We are providing a global key of the page title and provide it to the delegate as a constructor parameter. And then when painting the child, we will access the current context of the global key and then the height of the global key. Because at that paint phase, the page title is already laid out and we can surely get the height of it. Another thing to consider here is that Masha provided us for the pages which have hero image and which some of them don't have hero image. So the specification changes depending on the available presence of hero image. So we have the start point depending on the hero image existence. Now, should repaint or not repaint? This is the question. First of all, let's understand what this is about. To understand it, let's analyze its render object, render flow, which is the render object of this flow widget. So when we set the delegate, what we do is that we mark the layout as dirty or paint as dirty, paint stage as dirty. So if should repaint returns true, then in the next frame, we need to paint again. We need to call paint children again. Also, if this repaint has an update, then we will again need to paint this flow widget. Here, we provide a scroll position as repaint when constructing the flow delegate. Scroll position, as I mentioned, is a listener. It listens for the current scroll position, and yeah, we will pass it there. So here, when a scroll position value changes, it will be the widget will be marked as dirty. The children will be painted, and then if any of these values are different than the previous widget delegate, then we are again marking it as dirty. This was a bit complicated, but let's continue with this pagination. What is pagination? Pagination is sequence of screens that user goes one by one. So in the specs, you see a timeline and elements properties such as opacity, position, X position, and height, the size, changes according to this timeline. Again, the challenging part here is that keeping the heights of the pages same when we are having these transitions. We will see why this is challenging in the next slides. Okay, now this is the anatomy of a page. A page consists of a primary button, is optional, a back button. If it is the first page, we won't have it. The content is required. It's scrollable content. We have a close button and then top bar, which is visible when we scroll. Again, we will use the same approach as bottom sheet. Sorry, we will use the same approach as bottom navigation bar. Remember, in bottom navigation bar, we define the bottom navigation tabs. The bottom navigation tabs are not widgets, but they are configuration. And then inside the bottom navigation, they are created. So here, similarly, we will define the scrollable bottom sheet page properties. And inside the scrollable bottom sheet, we will create the children. For example, entire thing is a stack. We will place and position main content, top bar, close button, back button, and primary button accordingly. We have both ongoing, outgoing widgets and current widgets during the transition. What are these widgets? So we group the widgets to two. The widgets belonging to the outgoing page are inside this class, the components of this page. And then the components of the current widgets is is inside these current page widgets. We already have this off-stage main content again. I will talk about what it is about in the next slides. Okay, now let's go to the content of a button page. This is the root widget, value listenable builder. It has a page index listenable, which holds the value of page index. And whenever the page index changes, this triggers a build, and everything inside this is rebuilt. Now, here the important thing. We have this scrollable bottom sheet skeleton, which is a stateful widget. We will override did change dependencies and did update widget methods of this. Because when there is a new build, the widget runtime type and the key, they are the same. So element will be updated. The state will be reused. And then this time, the page index will be different. And that's how did update widget will be called. We will add a page with animation. But when we are first creating the state, we will just add a page without animation. Okay, how we add a page? We have one animation controller for each transition. This animation controller will rule entire animation, this 350 during 350 milliseconds. This is also called staggered animation. We also track this animation controller so that when it is completed, we will set the animator value to controller value to the upper bound, and the outgoing widgets will be null. We will delete them. We will get rid of them. And then during this adding page, we will set the before adding a new page, we will set the current page as outgoing page, and then start the animation controller if we have animations enabled. Sorry, yeah. Now the skeleton. This is actually skeleton holds these components in a switcher layout. Each component of the skeleton is this stack, which holds the outgoing, the widget from outgoing child and the widget from current child. For example, let's go into this animated builder for primary button. We have the primary button for the first page, for the outgoing page, and primary button for the new incoming page. And then we will have this transition. So the transition between these two buttons are given us by the motion designer with the motion specs. Depending on the motion specs, we set the begin time, end time, and the curve type, and the begin and end values. So when the widget is built, this animation will start, and then the transition will happen. Opacity, I guess, right? Yes. We are now analyzing the transition of the main content for the outgoing page. Here, the challenging part is, again, implementing the size transition, because we need to calculate a size factor according to the heights of the current and outgoing widgets. But we are in the build phase. We will use size transition widget. We cannot get the height in the build phase. Somehow we need to lay out the page and get the height. The off-state widget helps us here because it lays out its child as if it was in the tree, but it doesn't paint. So it only does the calculations, layout calculations. We will not see that the page is bigger now for some reason. Okay, here is what we will do step by step. First, we will create extra main content widgets for outgoing and the current page. And then we will assign global key to these extra main content widgets. We will wrap these contents with the off-state widget, and finally get the size from the global key. Okay, this is already a bit complicated, but I'm not going to details because we are already running out of time, and I will share my articles. There will be more information here. Please check the source code also. Let's stop here. Thank you for listening.